In this lesson, we're going to talk about logarithms, which is probably something you haven't dealt with before. If you take a look at this problem, it says 10 equals 2 to the x. So what we're looking for is we want to find what x equals in this problem, right? So when I'm trying to find what could be 2 to what power would equal 10, and we know that it's probably going to be not like 2 squared is 4, right? 2 cubed is 8. So let's kind of think through this. 2 cubed is 8, and 2 to the 4th is 16. So if we were going to guess what x is, we think it'd be 3 point some decimal, right? So probably closer to 3 than 4, and let's say like 3.2. Would that be a good estimate? So if we're going to actually solve this, what we're going to do is we're going to graph this on our calculator, except instead of putting the 10 in, because that's not going to help me graph it, I'm going to put in y equals 2 to the x. And then I'm going to actually go to where my y value is 10, so I can see what that x value would be. So if I turn my calculator on, I go to y equals, and I'm going to go ahead and plot y equals 2 raised to the x. And then I hit, now before I graph this, should this be exponential growth or exponential decay? Growth, because my base is higher than 1. So here's my graph. I'm going to do a zoom 6 here because this one zoomed out a little weird. There we go. Do you see my graph? So now I'm just going to trace on this graph until I find a y value that's 1. So I'm just going to hit trace and then see how I have a cursor here. So I'm looking at my y values right now, which you're going to be looking right here. That's where you should be watching right now. And tell me, well, obviously I'm not going to hear you, but pretend to shout at the computer or iPhone or whatever you're using when I hit a 10. So I'm going to keep going until my y value is a 10. Oh, right about there. See there? It's 10.5. So that answer for x, take a look at x, it's 3.4. Or if I go down, it's at 9.1, which is 3.2, which is what we guessed. So maybe 3.3, could we guess? So when I look at this, do you see how I can't find an exact answer for s based on my calculator? So when I look up here, we would say the best way to solve is not making an estimate off our calculator. We're not sure how to get x by itself in this equation. If I asked any of you to look at this original problem and I say, okay, here's 10 equals 2 to the x, and I want you to solve for x. We don't know how to do that yet. That's not something we've ever learned. And so what we're going to learn today is how to use what's called a logarithm to get those x's out of the exponent and be able to solve. We're not actually going to be able to solve ones like this yet. Today we're going to learn a lot about what logarithms are, but I'm going to bring you back to this problem in a couple days, and we're going to learn how to solve this using logs. And then you'll understand how we would get x, and we'll get an exact answer, not an estimate of 3.3 or 3.4, an exact answer for x. So to start that, we first have to learn about a log. So we would say the general definition of a log is log base b of x equals y. That's how we say that. Log base b of x equals y. A logarithm is the exponent y that makes b to the y equals x true, which made no sense probably, right? Do I sound like I'm speaking another language? So for example, here's a log. This would say log base 8 of 1 equals 0. So how we move this, this is considered logarithmic form. This is considered exponential form. See how it has an exponent, so it's an exponential form. This one has a log, the word log, so it's in logarithmic form. I would take 8 to the 0 equals 1. Does 8 to the 0 equal 1? Well, anything to the 0 equals 1, right? So that's true. So this is the two different forms, logarithmic and exponential. And you're not going to fully understand what this is yet until we start applying it and doing some things with it. So for now, if you're a little bit confused, you're totally normal. To kind of help with that, the best definition I can come up with that's kind of in our own words that would make sense to us is logarithms are the opposite of exponentials. Now we use the word opposite in quotes because we say, like if I say, what's the opposite of addition when we're solving? You guys all say subtraction. Really it's an inverse. That's technically the math term, but that's what you think of in your head. Oh, if I'm supposed to add, I subtract. If I want to get rid of it. If I'm multiplying, I divide. If I'm dividing, I multiply. So adding and subtracting are considered in our heads opposites. Technically they're called inverses. Multiplying, dividing, addition, subtraction. So in the world of exponents, and the opposite of an exponent, to undo an exponent, you use a log. Logs undo exponents, and exponents undo logs. So here is my trick that I use whenever I'm learning how to put things in logarithmic form versus exponential. Log base answer equals exponent, which probably makes no sense right now. But we should know that a base is the number that's in front of the exponent, right? So whatever we have here, let's say we have log base 5 of 25 equals 2. So I'm going to follow the vocabulary. Log base answer, this is my base, this would be my answer, right? And this would be my exponent. So to change from logarithmic to exponential form, I would say my base to my exponent. So 5 squared equals, and I'm calling this an answer. This is my made up thing. This is what I used to help me remember it when I was first learning it. So if you have another way, that's totally fine. But I just call this the answer, for lack of a better math term. So there we'd have 5 squared equals 25, and that'd be exponential form. So when I handed your notes out for this lesson, I gave you that big log that looked like you have no idea what you're doing with it. We're going to put all of our log rules on here as we learn them. So the first one, and probably the most important to start, is this one here. So take out your log sheet, and I want you to actually write log base answer equals exponent. This isn't something you're going to get to use on a test, but I want to have a place where we organize all the different rules for this chapter in one spot. So if you have this out while you're doing your Excel math or your worksheets, it's going to help you. And then by the time you're done with all that practicing, you shouldn't need this as a crutch for your test anymore. So that one I want you to put up first. And then we're going to actually practice moving forms. So these are both in logarithmic form. So for me to move from logarithmic to exponential, I would say it's base, so 2, to the exponent. Where's my exponent? It's right here, right? It's equals, so my exponent's -4, equals, and then my answer, 1/16. And you'll notice I'm making true statements here. 2 to the -4th is 1/16. I'm not giving you false equations. These are all true equations. So I want you guys to try B quick. Hopefully you got 5 squared equals 50 halves. And if you're wondering if you should write that as 5 squared equals 25, that's okay also, if you wanted to reduce that fraction, because we wouldn't normally leave it like that. You could. So there's me moving from logarithmic form to exponential. In the next couple now, we're going to move from exponential form to logarithmic. So I'm always going to say log, and then I have the base here. Well, what's the base in this problem? There's the base. This is my base. That's my exponent, which leaves this to be my answer, right? So I have log base, so 10, answer, 1,000, equals exponent. See how I'm copying this right here, helping me use that? So I would say log base 10 of 1,000 equals 3. So you guys try B. Hopefully you do log base 9 of 3 equals half. And there's my moving to logarithmic form. Now you're going to add that to your log. So you're going to write exponential form down and logarithmic form, and just give these examples so you can tell which one's which. So when you're asked to put something in logarithmic form, you realize it should look like that. And when you're asked to put something in exponential form, it should look like that. So add that. If you need to pause it so you have more time, go ahead. In this answer now, we're actually going to find some solutions. So we have log base 2 of 64, and we have to figure out what that equals. It's kind of hard because they don't give us an answer. They don't have an equation here. So what I do with these is I always write equals x. Then it's easier for me to move forms. So I would say 2 to the x equals 64. So take a look at that. I'm moving from logarithmic form to exponential. One of the things you'll really have to concentrate on in this chapter is when you're all of a sudden stuck in a problem and you think, I don't know what I should do. I don't know what to do. I'm stuck. Always change forms. That's almost always the answer. So when you go, I don't know what to do next, change forms. Move from logarithmic to exponential or exponential to logarithmic. But changing forms is almost always the answer when you get stuck on how to solve something. Now in A, what I do from here is, this is actually what we learned in lesson 10.1. I'm going to try to use my property of equality and make these be the same base. I know 2 to some power is probably 64, right? So 2 to the 4th we just did, right, was 16. 2 to the 5th would be 32. 2 to the 6th then is 64. So now that my bases are the same, I can say x equals 6. And I have just solved that log. So if I go to B, I have equals x again. So I'd say 16 to the x equals 2. I know I can rewrite 16 as an exponent with a base of 2. So 2 to the 4th is 16, right? And I'll keep the x there. And then this 2 doesn't have an exponent, so we hopefully know that that's a 1. So I'd have 4x equals 1, so x equals 1/4. I think these are kind of fun, actually, so hopefully you do too. And then in C, I go equals x again, so switching forms, 2 to the x equals 1/32. 2 to the x equals, and I know 32 is the same as 2 to the 5th, right? So when I move that to the numerator, I'd have 2 to the -5, which gives me x equals -5. So there's a few examples of that. The next ones we're going to do are solving logarithmic equations. So we have log base 2 of x equals 3. So all we have to do here is move to exponential form. We would say 2 cubed equals x, which is 8. X equals 8. So really, these are easy problems once you're good at switching forms. That's what's going to be new to you, is changing from logarithmic to exponential, so you might have to look at your sheet a lot for that. But after that, the solving's pretty easy. This one would be 9 to the 1/2 equals x. And remember, 9 to the 1/2 is the same as saying the square root of 9. So we would get 3. If you're wondering if it should be plus or minus 3, remember we don't do that unless we square root both sides of an equation. That's when we'd have to give both values. Letter C, we'd have 4 to the 3/2 equals x. If you punch this in your calculator, you're going to get an answer. Or you could write this in radical form, the square root of 4 cubed. Well, the square root of 4 cubed is 64. Square root of 64 is 8. Oops, let's make that an x. Or if you would have gone the other way and said, oh, the square root of 4 is 2, 2 cubed is still 8. So either way you go, you get the same answer. And then the last one like this, we would say a squared equals 16. And now I did have an a squared here, right? So I'm going to square root both sides. So I do need to write a equals plus or minus 4. If you remember from our 10-1 lesson, we have exponential growth if our base is greater than 1, and we have exponential decay if our base is between 0 and 1. I don't have anything negative. So when I get a base, because remember this part is your base, isn't it? See the word base there? I can't have a negative base. So this really is an answer of a equals 4 and a equals -4. The only one that would work is the positive. I can't have a negative base. And I'll show you why in a few problems here. The last thing then that we're going to talk about is our property of equality for logs. So if we have the same log and base, meaning log base 5, log base 5. It's just like having the same base for our property of equality that we did the other day. We can then set the of part equal to each other. So I can say x plus 7 equals 2x. And then when I solve that, I would get x to be, oops, let's write that. I would get 7 to equal x. So I get x equals 7. In B, I have the same log. So remember, you have to have this. You have to have the same log and base for you to set them equal. So I'm here. You get 9x equals 81. X equals 9. And these go really quick once you know how to set them up. They're very easy algebra problems for us. In C, same log and base. So I'd say p squared minus 2 equals p. When I look at this, I see that I have a p squared and a p, so I'm thinking I'm going to have to factor this. So I'm going to minus p from both sides. P squared minus p minus 2 equals 0. So I'm going to go ahead and factor that. I'd have p minus 2, p plus 1. So we get p minus 2 equals 0. P plus 1 equals 0. So I get p to be 2 and p to be -1. Now my p, we can't have it be negative. That's another one of ours. So we're going to just use the positive value here. And our p is a positive 2. Here's the graph I'm showing you for why we can't have a negative log. So here's an example of a negative base. If I was to plot these points, like I took it to the first power, to the second power, and I plot this graph, when I graph this, this is what it looks like. So it's not giving me exponential growth or decay. It's kind of not sure which way it wants to go, because it's going to switch signs every other time. 2 to the first would be negative 2. 2 squared is 4. Negative 2 cubed is negative 8. Negative 2 to the fourth is 16. See how it switches signs every time? And so it's not going to give me an exponential growth or decay problem. In this case, it should be growth, but that's not possible for us. So hopefully those made sense. Your objectives that go with this video lesson are 110 to 113. And so you'll be getting those in class tomorrow. And let me know if you have any questions.